Hello YouTube. In this video I'm going to talk about observability, and I'm going to suggest a new way of drawing the distinction between observables and unobservables. This is relevant to the scientific realism debate, so this video will probably make more sense if you've seen my series on scientific realism, particularly the 6th video on observation. But let me start by giving just a little bit of background to remind everybody where we are. So, scientific realists hold that science aims to give us theories that are true in general, and that the entities and processes described by those theories really exist. So there really are genes and electrons and mitochondria and black holes, and these things really do behave in the ways described by our best theories. By contrast, constructive empiricism, which is one of the most prominent forms of anti-realism, holds that science aims to give us theories that are empirically adequate, where a theory is empirically adequate just in case it correctly describes the observable phenomena. Basically, constructive empiricists view scientific theories as tools for systematizing, predicting, and controlling what we observe. Theoretical entities that are unobservable, such as electrons, should be viewed as useful fictions. Now, there are many different aspects to this debate, but one of the central questions here concerns what is observable. One way that realists have responded to anti-realism is by attacking the distinction between observables and unobservables, or at least by trying to extend the boundaries of the observable. Realists tend to hold that scientific instruments have extended the reach of our senses. Grover Maxwell famously argued against the unobservable distinction, or at least against the epistemic significance of that distinction, that there is a continuous series from, and I quote, looking through a window pane, looking through glasses, looking through binoculars, looking through a low-power microscope, looking through a high-power microscope, etc. Just as we observe the world through a window, we can observe the world through an electron microscope. We literally see the bacteria and mitochondria. For the realist, scientific instruments are, as Bas van Frassen once poetically put it, windows on the invisible world. By contrast, constructive empiricists see scientific instruments as engines of creation. For an empiricist, instruments produce new images that must be accommodated by scientific theories, but there is no need to assume that these images correspond to any real objects. What is shown by an electron microscope might, for all we know, be a kind of illusion. So even though we have these instruments, bacteria and mitochondria and things like that are not actually observable. Now, an interesting new argument against the constructive empiricist has recently been proposed by Toon in his article Empiricism for Cyborgs. Toon suggests that the extended mind thesis can be used to support realism. So according to the extended mind, cognitive processes can extend beyond the brain and even beyond the body. Objects in the external environment can literally form part of our minds. Now, there are many different ways of developing the extended mind idea, but Toon focuses on the arguments given by Andy Clark and David Chalmers in their 1998 article, The Extended Mind. Clark and Chalmers motivate their view with the now rather famous example of Otto and Inga. So imagine these two people, Otto and Inga. Both of them want to visit the Museum of Modern Art. Inga is a normal adult, and she simply remembers that the museum is located on 53rd Street, and she heads off. Otto, on the other hand, has Alzheimer's, and he carries a notebook with him in which he records important information. He looks up the location of the museum, he sees that it's on 53rd Street, and he sets off. Now, Clark and Chalmers say that the notebook is literally part of Otto's memory, and whatever's written in Otto's notebook forms part of his set of beliefs. They think it would be true to say that Otto believes the museum is on 53rd Street even before he looks in his notebook. And the point is that Otto's notebook plays the same functional role in his cognitive life as the part of Inga's brain that encodes memories does in hers, right? So that part of Inga's brain and Otto's notebook both play the same functional role. Clark and Chalmers then state what has become a key idea for the extended mind, which is known as the parity principle, which is as follows. If, as we confront some task, a part of the world functions as a process which, were it done in the head, we would have no hesitation in recognizing as part of the cognitive process, then that part of the world is part of the cognitive process. So if the information that is written down in Otto's notebook were instead encoded inside his brain, we would have no hesitation in considering it to be part of his memory. Indeed, we might imagine a Martian or a robot which literally has loads of little notebooks inside its head that form its memories. We'd count that as part of its cognitive process, as part of its set of beliefs. So by the parity principle, Otto's notebook really is just part of his memory. Now, of course, this principle is somewhat vague, but the basic idea is that we should abandon our prejudices about where cognitive processes can be located. There is no need to assume that cognitive processes are limited to the brain. That's the basic idea. Now anyway, Toon suggests that by this same argument, we should conclude that scientific instruments extend perception. A scientific instrument can literally be part of the scientist's perceptual process, just as Otto's notebook can be part of Otto's memory. And this means that when the scientist uses the instrument, she literally perceives objects through them. By looking through a microscope, we create an extended perceptual system that allows us to directly see microbes. So Toon formalises his argument along these lines. I've changed it slightly, but basically this is what he says. Object X is detectable using instrument Y, but it's not detectable with the unaided sensors. If Y were in the head of a Martian, it would count as part of the Martian's perceptual process. So, by the parity principle, Y forms part of the scientist's perceptual process, and therefore we can perceive X. Remember, the parity principle tells us that if there is some process that we would instantly recognise as a cognitive process were it done in the head, then that process is a cognitive process. So for any scientific instrument, just imagine a Martian which has that instrument literally inside its head, or at least which has a mechanism inside its head that functions just like the instrument. If we would judge this to be part of the Martian's perceptual process, then we should also accept that it forms part of the perceptual process for the scientist. So to make this maybe a bit more clear, take, for example, the optical microscope. Now imagine a Martian with a mechanism in its head that can detect what is detected by the human eye plus the optical microscope. In the case of a single lens microscope, we can literally just imagine a Martian with a visual system that is essentially the same as the human visual system, except the lenses of its eyes have a far smaller diameter. Actually, we don't even need to imagine a Martian for this one, because there are creatures that already exist on this planet that have lenses with far smaller eyes that would allow them to detect what we can detect with a single lens microscope. Anyway, we would say that these creatures visually perceive cells and bacteria. So, by the parity principle, a human being using a single lens microscope also visually perceives cells and bacteria. The single lens microscope extends the human perceptual system. And a similar story can be told for many other scientific instruments, or so it seems at least. So for any instrument you like, you can imagine a similar mechanism inside the head of an intelligent Martian. We would count this as a perceptual process. So we should say that when scientists use that instrument, it also counts as an extended perceptual process. Now obviously, the extended mind thesis in general is very controversial. One way to resist this argument that Toon has presented would be to just reject the extended mind in general, or the parity principle in particular. But I'm going to take a different line here. Let's grant that the extended mind hypothesis is correct. I'm going to do two things. First, I'm going to present an alternative empiricist way of thinking about scientific instruments that still respects the insights of the extended mind. And then secondly, I will criticise the use of the parity principle in arguments that instruments extend perception. I don't think the parity principle can be applied in the way that Toon has applied it here. Firstly, the alternative view of scientific instruments. Well, I think the best way to motivate my alternative view of instruments is by contrasting optical microscopes with other types of microscopes, because I'm actually willing to say that if the extended mind hypothesis is true, then actually it's quite plausible that optical microscopes do indeed extend visual perception, so that we literally see through an optical microscope. Now, if that seems like a significant concession, it's worth noting that even Bas van Frassen, who is by far the most famous anti-realist, is actually rather nonchalant about the idea that we see through optical microscopes. In his article, Constructive Empiricism Now, he says that all that's really important to him is that it makes sense to draw a line between instruments that reveal the world as it is and instruments that simply create new phenomena. He's happy to allow that the optical microscope reveals the otherwise hidden world, but he wants to resist treating the electron microscope this way. However, he doesn't actually give us any principled way of drawing the line, and that's what I want to do here. I think there is a significant difference between optical microscopes and other instruments. But to see this, we need to consider how an optical microscope works. Well, an optical microscope shows us an object in visible light using a system of lenses to magnify the objects. This is very similar to the mechanism of the human eye, which uses a lens to refract visible light. Indeed, the simplest microscopes, such as, simplest microscopes, original microscopes were just single lenses, and you can see that on in the diagram at the top here. A spherical bead of glass acts as a magnifier, and the smaller the diameter, the greater the magnification. Single lenses can be quite powerful, actually. Van Leeuwenhoek, I'm not sure if I'm pronouncing his name correctly, but the bloke who is famous for discovering all sorts of things with a microscope in the 1600s, Van Leeuwenhoek, some of his lenses achieved a magnification of up to about 500 times. Modern compound microscopes can magnify about 800 times with lenses alone, and something over 1,000 times with oil immersion. Anyway, you can see here a diagram of a simple compound microscope and a simple single lens microscope. They use lenses to refract visible light. And as I've noted, there are mechanisms very similar to, say, a single lens microscope that already exist in small animals. Now, the resolving power of optical microscopes is limited by diffraction. We can achieve greater resolving power with different mechanisms. One such mechanism is found in atomic force microscopy. So this is a diagram of an atomic force microscope. So we have this thing called the cantilever. The cantilever is a long rod with a sharp tip at the end, and the point of the tip consists of literally just a few atoms. The cantilever is moved across a sample, and the forces between the tip and the surface of the sample deflect the cantilever up and down, depending obviously on the topography of the sample and the chemical constituents of it. Now, a laser beam is pointed at the top of the cantilever, and the beam reflects from the top of the cantilever into a detector. As the cantilever moves up and down, it deflects the laser beam, and by tracking how the laser is deflected, a computer can build up an image of the topography of the sample. Now, I'm saying there's a significant difference between these two instruments. And that difference is as follows. When we use an atomic force microscope to detect X, the detection of X is necessarily indirect. The atomic force microscope produces a literal image on a computer screen, and we see X only via seeing the image that represents X. This information about X could of course be delivered in some other way. The microscope, I suppose, could produce sounds, or it could construct an object that could be touched. But either way, our access to X will always be indirect in the same sense. We can access X, we can access the properties of X only via an artifact which represents X, which is produced by the microscope. An artifact which can be detected by means of the unaided sensors. In contrast, when we look at X through an optical microscope, we are not looking at an artifact that represents X. So if I use a lens to view a mitochondrion, I can see that the lens is transparent and that there is not a literal image of a mitochondrion inside the lens. Now, of course, we do talk about lenses creating real images and virtual images, but these are technical terms that refer respectively to where light rays converge and where light rays appear to have converged, I think. Or have I got that the wrong way around? Anyway, they're technical terms. Real images and virtual images are not material objects. There is not literally an image. Like, there's not literally a material object inside the lens of an optical microscope. No more than there is a literal image inside the lens of a magnifying glass. So in this respect, an optical microscope is no different in kind from a powerful magnifying glass or even a window. We simply see through these things. These things do not produce artifacts. They do not produce images. So in these cases, our perception of the object is direct. If we return to Van Frassen's metaphor about windows on the invisible world versus engines of creation, the point is that there is a sense in which even the realist has to accept that atomic force microscopes are engines of creation. They create a literal object for inspection, and we may treat it as accurately representing unobservables, but there's no doubt that it's a new object. On the other hand, no new object is created by an optical microscope. When we peer through an optical microscope, there is no artifact about which we can ask, well, what, if anything, does this artifact represent? This is a question that can be asked only about the output of something like an atomic force microscope. Now, I take it that this is a significant difference, which is completely lost if we just view scientific instruments in general as extensions of perception. What I want to suggest is that the line between instruments that can plausibly be taken to extend perception and those that cannot is where the only access to the information provided by the instrument is via an artifact generated by the instrument. And that, of course, is how the majority of scientific instruments operate. The majority of them only communicate the information by producing some artifact for us to then inspect. And this provides us with, I think, a fairly clear line between the observable and the unobservable. Recall Maxwell's idea that there is a continuous series from looking through a window pane, through glasses, through binoculars, through a low power microscope, through a high power microscope, etc. Well, that's fair enough, provided we're considering only optical microscopes, no matter what their magnification. But when we get to what Maxwell simply calls high power microscopes, things like electron microscopes and atomic force microscopes, there's actually a significant discontinuity. And that's that, we don't in any sense look through these instruments. You don't look through an electron microscope or look through an atomic force microscope. They can work only by creating physical images, by creating material objects that we then visually see. I mean, it's worth noting that this difference is presupposed by scientists themselves. Recall again the instrumental model of the optical microscope that I showed. This model, if you go back to it, you'll see it includes the human eye at the left. The model must depict a receiver of some sort at the left. Without this, it wouldn't properly show how the optical microscope functions. This receiver need not be a human eye, of course, but it can be. Now, if you compare that with the instrumental model of the atomic force microscope, well, none of the parts there could be replaced with a human sensory organ. So, the idea then is that what's missing in images created by atomic force microscopes is a certain kind of directness. Since the object that it reveals, the object that is revealed by an atomic force microscope is detected only via perceiving another object. Now, of course, this does raise a question of, well, what exactly is meant by directness in general? Well, unfortunately, I'm not really sure how to define that for perception in general, but to begin developing the idea, I'd suggest that visual perception of an object seems to require detection of light that has interacted with the object and or its surroundings. So I can see a mountain by detecting light that has been reflected by the mountain. Light hits the mountain, some is absorbed, some is reflected back and hits my retina. Perhaps we would say that an object is seen when it blocks light, as when we see a silhouette. Here we detect the object by detecting the light around it. Either way, what hits our eyes is light that has interacted in some way with the object or its surroundings. Now, this condition holds for optical microscopes. When you view a mitochondrion through an optical microscope, the light that hits your eye is light that was reflected off or transmitted through the mitochondrion. And so we have a kind of direct connection to the mitochondrion. But when you look at an image of a mitochondrion created by an atomic force microscope or a photograph or whatever, you're not seeing light that was reflected off or transmitted through the mitochondrion. So possibly a necessary condition for visual perception has something to do with this, with light. It's it's about light that has interacted with the object and or its surroundings. Obviously that's not a sufficient condition because light is transmitted through air, but we don't visually perceive air. Now, atomic force microscopes lack directness in another sense also. If an atomic force microscope extends perception, then it does this only by being parasitic on our ordinary perceptual capacities. So we perceive the nanoscale object only via perceiving another object, a macroscale object, and that object is perceived in a normal way through the normal capacity of sight. Phenomenologically, looking at an image created by an atomic force microscope is just like looking at any other image. It feels like seeing, it feels like visual perception. Indeed, there's no question that this is what we are doing. We are visually perceiving an image. But if the atomic force microscope extends perception, the perceptual process in question is not actually a form of seeing. So we shouldn't be misled by the fact that the atomic force microscope produces an image. The information that the microscope generates could be communicated in some other way, as I noted earlier. You could create a sound file or an object that could be touched, for example. It produces an image because we happen to find visual imagery easier to use and understand. But obviously the actual mechanism of atomic force microscopy is nothing like vision. I guess you could be tempted to say that it's a kind of touch. The cantilever moves along the sample. Colloquially, we might say it touches the sample. It's not really clear that this works either. Remember, the cantilever tip is literally just a few atoms in width, and the repulsive intermolecular forces push the tip away from the sample. These forces and how they interact with the cantilever will differ depending on the sample, and any inferences about the measurements of the topography of the sample or of the composition of the sample or whatever are based on physical theory concerning the intermolecular forces of the sample and how they will affect the cantilever tip. In fact, the mechanism of the atomic force microscope isn't really anything like the mechanism of any of our sensors. So if the atomic force microscope extends perception, it should probably be treated as creating an entirely new perceptual capacity. It certainly isn't anything like vision anyway. And the same is true for many other scientific instruments. An electron microscope, for example, involves firing a beam of electrons through a sample. That's not analogous to any of the sensors we currently have. So now the extended perception view faces the rather odd situation that an entirely new perceptual capacity feels very much like vision. Indeed, what's going on in the brain and the nearby environment is exactly the same as vision. And I think the oddness of this situation is brought out quite clearly if we imagine looking at two images that are qualitatively identical, where one was produced by an atomic force microscope and the other is just a pattern of random noise that just by chance created the same image. To look at the first image is to engage in a wholly new form of perception. To look at the second image is just to look at an image, right? That seems a bit strange. That's an odd result, I would suggest. And notice that this is not a problem for optical microscopes. An optical microscope can be treated as simply extending perceptual capacities that we already have, namely vision, precisely because it has the directness, right? You don't perceive what you don't. The optical microscope doesn't allow you to detect something by creating some other thing that you then perceive via the normal mechanisms. So anyway, that is an alternative view of instruments. I'm willing to grant that some instruments do extend perception, but only a very narrow class. More generally, I suggest that observability can be defined in terms of whether or not the instrument communicates information via generating an artifact. Now, realists might object at this point. The realist can grant that there is an important difference between instruments in terms of directness, in terms of the access they provide us to the world, but the realist might still insist that I haven't dealt with the extended perception argument. I mean, everybody recognises that there are differences between different perceptual processes, right? Sight is not the same as touch. Maybe we should just say that atomic force microscopes do extend perception, but they do so using an unusual mechanism, where this mechanism involves the creation of an artifact that is then visually perceived. So I admit that so far this is just an alternative way of thinking about instruments. I haven't yet dealt with the argument based on the parity principle. So let's turn to that. Okay, as I mentioned earlier, obvious option here is just to reject the parity principle. It's certainly controversial, but I'm going to grant it for the sake of argument. Let's assume that it's true. And if we accept the parity principle, then the conclusion that scientific instruments extend perception does seem to follow fairly straightforwardly. Imagine a Martian with an atomic force microscope in its head. Surely, despite what has been said so far, we would say that this is part of the Martian's perceptual process. You know, a Martian with atomic force microscope eyes is perceiving all of that stuff on the nanoscale. So by the parity principle, the atomic force microscope extends scientists' perceptual processes, even if it does this by sort of parasitizing vision. Now, I think that this thought experiment is fairly seriously misleading in at least two ways. So, first problem. What we are tempted to imagine when we imagine the atomic force microscope Martian is that the output of the atomic force mechanism in the Martian's head is not an artifact that is then made available for the Martian's examination, but is simply immediate sensory data. So in just the way that human vision produces immediate sensory data, right? When you open your eyes and look at something, you don't literally generate an image. It's not like you literally generate a photograph that you can then kind of manipulate and perceive in some other way, right? And I think that when we imagine the Martian with the atomic force microscope in its head, we just imagine something that delivers immediate sensory data. But this is just to ignore the difference that I have outlined earlier, namely that the atomic force microscope, unlike the optical microscope, produces an artifact. And when we adjust the thought experiment to account for this difference, I would submit that we don't have the intuitive judgment that the Martian with the atomic force microscope in its head is actually perceiving anything. When we build into the thought experiment the point that the atomic force microscope works by creating a physical image, I think we no longer have that intuitive judgment that it is a perceptual process in the Martian. So I think it's best to see this by considering a slightly different example. Take photography. A photograph creates an image of a scene that can be highly realistic. Indeed, ideally, a photograph looks exactly like the original scene would look if you were viewing the scene from the same vantage point as the camera. When we look at a photograph, we know that it accurately represents what it depicts, provided it hasn't been retouched at least. So this is a case where questions about realism and anti-realism don't arise, because we all agree that photography can reveal the world as it really is, since we could in principle perceive the objects depicted in a photograph without the aid of the photograph. So you might want to ask, well, on the extended mind hypothesis, do photographs extend our perceptual capacities? When I look at a photograph of Abraham Lincoln, do I literally see Lincoln? Well, I don't think so. I actually have a video about this called Philosophy of Photography, Realism and Transparency, I think it's called. But anyway, the point for now is whether the parity principle helps. So let's imagine applying the parity principle to this case. Let's apply the parity principle to this case. So imagine a Martian that has in its head a mechanism that functions just like a camera. This mechanism produces an image of whatever the Martian is looking at. A literal physical image that is stored inside its head in a file of images that it can then flick through when it wants to revisit them. One day the Martian witnesses a crime, it creates several images of the crime which it later revisits in order to answer questions about the crime. Now, intuitively this is a cognitive process, but is it perception? Well, surely it would be more naturally classed as a kind of memory. Literally a photographic memory. So, what this thought experiment establishes, if it establishes anything, is that there are circumstances where a file of photographs can count as an extended memory, but perception through a photograph, I would suggest, is no less bizarre when it's going on in the head of a Martian than under normal circumstances. So the parity principle really doesn't lend any support to the claim that photographs literally extend visual perception. And I mean, the moral for the atomic force microscope should hopefully be clear. If even a photograph, which we all agree accurately reveals the genuine structure of the world, does not extend perception, then a physical image produced by an atomic force microscope surely doesn't either. I mean, really, a photographic camera and an atomic force microscope are just two different ways of producing images. The end result, the end product, is the same type of thing. When we imagine something in the head of a Martian that produces literal physical images that are stored in some literal physical file, that doesn't seem like a perceptual process. Or at least that's my intuition on that one. Maybe you have a different intuition. In which case my argument just doesn't work here. But it seems to me that once you acknowledge the difference in directness, once you build into the thought experiment the point that the atomic force microscope creates an artifact, I think it no longer is intuitive to consider it a perceptual process, even when it's going on in the head of a Martian. But that's maybe, I think, the more minor point. Here's the more serious problem with the appeal to the parity principle. So the second problem with the Martian thought experiment is that given how instruments like atomic force microscopes actually work, it's just completely implausible to suppose that they could ever be part of the head of any organism. Now, of course, philosophers often appeal to thought experiments, sometimes quite outlandish, to defend their views, and I don't want to object to thought experiments in general. The real problem in this case is that it's not at all clear what it is we're being asked to imagine. So I think we're tempted by the idea of a Martian with atomic force microscopes in place of its eyes. So it wanders around the world and it points its atomic force microscopes at things, and then it receives information about those things. And like, okay, maybe intuitively that's a perceptual process. Maybe you want to call that a perceptual process. But of course, that's just a fantasy. You don't point an atomic force microscope at anything. You place a sample under the cantilever. These samples have to be carefully prepared. First, the sample must be cut to an appropriate size, then it must be fixed to an appropriate substrate to prevent any movement, which would otherwise interfere with the measurements made by the cantilever. Chemicals may need to be applied to make certain features more or less salient. I mean, the same is true for other types of sophisticated microscopy. When using such instruments, we first have to create an artifact that can interact with the instrument in the right kind of way so as to produce a usable image. And I think this is where the window on the invisible world metaphor really breaks down. Even if there were some way of getting an atomic force microscope inside the head of an organism, such a creature simply could not use it in its interactions with the world in anything like the way any other perceptual process is used. And I mean, if you just read about the details of any sophisticated microscope or sophisticated scientific instrument, you're going to find the same kind of thing. There's this fairly technical and sophisticated process of preparing the samples and preparing the instrument. You can't just like point it at things. Optical microscopes are different. Like when we imagine a Martian with an optical microscope in its head, we're imagining an organism that is very much like the organisms that we are familiar with. For this thought experiment, we can simply imagine an organism with lenses of a smaller diameter in its eyes, or with some complex system of lenses in its eyes. That's fine. Like you could totally have an organism that has a more sophisticated system of lenses, or that has smaller lenses that walks around and points these lenses at things. But when we try to imagine a Martian with an atomic force microscope, or with some other mechanism that magnifies as much as an atomic force microscope, like what would that organism actually be like? Would we still suppose that there's a perceptual process taking place here? I mean, the previous example of the Martian with the photographic camera in its head, which I think intuitively counts as a kind of memory rather than a kind of perception, should illustrate that we maybe can't rely on our intuitions about whether some mechanism is a perceptual process until we're able to state specifically how that mechanism functions within the organism. Maybe it would be possible to provide a thought experiment where the mechanism is described in detail and where our intuitive judgment is that it's a perceptual process, maybe, but then it's probably also going to be possible to provide a thought experiment where the mechanism is described in detail and our intuitive judgment is that it's not a perceptual process. I think when it comes to stuff like the atomic force microscope and electron microscopes and other sophisticated scientific instruments, I don't think the parity principle really helps support the claim that these things extend perception, because I think that it's just not clear that they would intuitively count as perception if they were in the head of some other organism. Now, there are, of course, other arguments for extended perception that do not rely on the parity principle. And perhaps these arguments could be applied to the case of scientific instruments. Toon himself mentions two of these arguments. So one is close coupling, which involves an organism and some external device being connected in stable and reliable ways so as to successfully solve cognitive problems. And he also mentions phenomenological arguments. Now, I'm not going to explain these in any detail because I think they can both be dealt with very swiftly. Close coupling is simply not possible for sophisticated instruments like atomic force microscopes. Maybe it would be possible for a person to carry a simple optical microscope everywhere with them and to use it enough in their dealings with the world that it counts as closely coupled to them. Maybe. I think that's probably unlikely. People don't tend to use optical microscopes all that often, but in any case, very few scientific instruments are so user-friendly. As for the phenomenology, well, I've already commented on this. Looking at an image produced by an atomic force microscope is just like looking at an image. It doesn't have the different phenomenology that would be expected of a new perceptual process. There is another argument that is not discussed by Toon, which is enactivism. So enactivism proposes that perception does not involve the mind mirroring or representing the world, but it's instead a kind of relational process arising from the interaction between the organism and its environment. So perception arises from the organism exercising skills and abilities in its environment. On this view, perception is tied to action. We perceive the world in order to do various things in it. And in particular, the idea is that perception involves exercising our knowledge of what are sometimes called sensory motor contingencies, which are regularities in the way that sensations change as a result of bodily movements. As I move towards a black object, for instance, my visual sensations will change in regular, predictable ways. The blackness will increasingly fill my visual field, and the blackness will occlude more objects previously in my visual field. In general, I know that an object will appear larger as I approach it. I know how its apparent angles will change as I move around it. I know how it will feel if I pick it up and how much force to use when doing so. I know how moving will reveal things occluded by the object. So in J.J. Gibson's language, we see the environment as affording various possibilities for action. Now, enactivism, I think, provides no comfort for the realist. If anything, my claim about the fundamental difference between perceiving X and perceiving an image of X is especially well suited to the enactivist view. On my desk is a cup and a phone. I know that as I move around, different parts of the cup and the phone will be revealed. I know that as I move around, at times the cup will occlude the phone, that some parts will be in shadow and other parts in light. The cup and the phone both afford various possibilities for action, in that I could throw the cup and use it to smash the window. Now, suppose I look at a photo of the same scene. Well, as I move around the photo, the image of the cup doesn't occlude the image of the phone. I can't use the image of the cup to smash the window. The affordances of X and the affordances of an image of X are very different. And as we've seen, the output of an atomic force microscope is merely an image. The sensory motor contingencies are just the same as they would be for a photograph or a painting. Indeed, it's not obvious on the enactivist view that we could even treat optical microscopes as extending perception, right? But in any case, certainly I don't think we can treat atomic force microscopes as extending perception. So I suggest that there is not yet any good reason to think that instruments in general literally extend perception. Maybe there are a few examples like atomic force microscopes, but none of the major theories of extended perception apply to the majority of scientific instruments. Okay, well, that's all for now. Thanks for watching.